Here we have that a researcher wishes to estimate the percentage of adults who supported abolishing the penny. What size sample would be obtained if he wishes to estimate the estimate to be within 4 percentage points with 95% confidence interval? So here we have a formula for n if we have a prior estimate. And that prior estimate was 28% or 0.28. So furthermore, because we are talking about, just like in this example, a 95% confidence interval. Okay. Outside of 95% would be 5%, but that would be in both tails total. By the symmetry, 2.5% or 0.025. The closest z-score, there's nothing with 0.02 in the negative 2.1 row. We have things less than that, 0.022. Here it starts off higher. Right there. Negative 1.96 would give us 0.025. Okay. Well, let's see. Whether I said negative 1.6, 1.96, or positive, that's going to get squared anyway. One more thing. Let's see. So P hat from the prior estimate was 0.28 times 1 minus that times, we're going to be squaring the 1.96 over the margin of error. So the margin of error was supposed to be within 4 percentage points. Okay, so this was already in terms of a percentage. Wait a minute. Let's try 0.04. Whoops. 0.28 times 1 minus 0.28 times, in parentheses, the critical z value 1.96 divided by the margin of error. I think I need that as a decimal, just like the 28%. That whole thing in parentheses is getting squared. Round that to the nearest, round up to the nearest integer. So that's going to round up to 485. If you check out my videos on margin of error and sample size for population means, you'll get a little explanation about why we're rounding up instead of the usual rounding way. The usual mathematical rounding would round that to 484, but these always have to get rounded up. Does not use any prior estimate. I've got a guess here, but let me double check what's in the textbook. Or we could let p hat equal 0.5. Why am I not surprised? Round that up to 601. See if they agree with that. Okay, that's good.